second webinar in our short spring series on Calculus 1 with corequisite support. And back for a second time is Lisa Morales and Paula Young from Mount San Antonio College. I'm Myra Snell. I'm a professor of mathematics at Los Medanos College, where I've been for 31 years. And I'm the co-founder of the California Acceleration Project. Just a few logistical questions or issues before we get started. One is that this presentation will be recorded. And if you registered for the webinar, I sent you a Zoom link, so I have your email address, and I will be emailing you a link to the recording and a link to a folder with resources that Lisa and Paula will be providing. You will also find this webinar posted on the California Acceleration Project's website, which is accelerationproject.org. And under publications, you'll find the webinar, the PowerPoint, and the resources we're providing. Today, we are trying something new because we have so many participants signed up for this webinar. We are not going to be using the chat function. We're going to be using the Q&A. And part of the reason we're doing this is that at the last webinar, Zoom has this new feature where if somebody enters a comment in chat and somebody else responds to it, it bumps to the top of the list. So we had so many people participating, we had trouble tracking the questions because people were responding to each other and their posts were jumping to the top and we couldn't keep track of the questions. So today what we're going to do is try the Q&A function. What's going to happen when you enter a question, you'll see a Q&A option at the bottom of your screen, is that the question will not appear until until either Lisa or Paula responds to it. If they respond in writing, everybody will see the question and the answer. If they decide to respond to it verbally, you'll just see the question and you'll hear them answer it. If we have questions that we don't have time to get to by the end of the webinar, the three of us are going to put together a curated FAQ, and that will come with the email that I'm sending you, and it will also be posted on the CAP website so that you'll be able to see questions that didn't get answered and have the answers there. Okay, are we recording?
Yes.
All right. So I'm going to hand things over now to Lisa and Paula.
Great. Hi, everybody. Happy Friday. Welcome to our second session where we're going to be talking about our Calculus 1 with support class. We are both from Mount San Antonio College, and we're going to start with a brief introduction. For those of you who couldn't join us last time, a little bit about myself. I'm Lisa. My background before starting at Mt.SAC, I was a high school teacher for about 5 years, teaching mostly pre-calculus and AP calculus before I switched on over to Mt.SAC, where I've been there for 7 years as a full-time instructor. And then just pertaining to the session today, I have been a co-leader for many math department community of practice events and natural science community of practice events. So just really big on professional development and working on our classes, what we do in the classroom. That's sort of my background. And I'll turn it over to Paula.
Hi, I'm Paula Young. Like Lisa, I also taught high school for a little bit longer, for 11 years, and then I switched over here to Mt.SAC. I've been teaching at Mt.SAC for 15 years, and with Lisa, I have co-led many math department and division-wide community of practice events where, again, we focus in on our students and our teaching and just some really good conversations that we've had with faculty from our whole division. And so I just wanted to start off by saying, we don't consider ourselves necessarily experts any more than you guys are in terms of teaching. We have been doing this corequisite though for a little bit longer than most other schools. We started offering our corequisite in 2018. So we're just bringing our knowledge that we have so far and sharing it with you guys, not only our good things, but maybe some of the things we've tried that haven't worked and different things it's a growing process. We're all growing and learning as we go through this together. So our philosophy, our work is equity driven. So we strive to bring a sense of welcomeness and belonging to our classroom for our students, and we aim to have class policies that are rooted in equity. We want students to stay motivated to pursue their STEM degrees regardless of their mathematical background. So we try to help them develop what we call their STEM identity, and we ask them to find their why, like what's their purpose, why are they here, why are they in this class, what's their goal. And we believe in also helping students to build study skills and other habits for success, because we care obviously about the whole student, not just how they do in their math class. And we also feel like those skills will help them as they move on, whether they're a bio major, chem major, physics major, whatever they tend to be. And we do try to engage in active learning as much as time permits us in our classrooms.
So we know that some names here look familiar and that you were with us for our last session, but if you weren't, and even if you were, it's always nice to do a recap. So we're going to do a brief recap of the last session, just to kind of reintroduce you to what goes on in typical sort of class pattern. But just so you know, the full recording can be found on the CAP website, and Myra will be sharing with you all the resources that we provided last time, and then those that we're going to share this time as well. So just some basics, the support class model at Mt.SAC. Our Calculus 1 class is Math 180, and our Calculus 1 support course is Math 18A. So we might, slip up and reference those course numbers. Our support class is a 2-unit class that is pass, no pass, and gives the professor 2 extra contact hours with our students per week. The target course and support course are considered hard linked, so you can't drop one without the other. So it's the same instructor, right, for both courses. The instructor can determine when to weave in support content. It doesn't just have to be during the set time for the support course. Currently, our model is that students are eligible for our calculus class if they've passed high school pre-calculus with a C or better. And all of our support courses are optional. There is no GPA band where they are required.
So what we're going to do now is talk a little bit about how we run our calculus with the support class.
And when we say we mean literally Paula and I. So not all courses at calculus courses at Mt.SAC.
Yeah, I'm sorry. Yeah. So Lisa's going to try and do a split screen here where she shows the slide and the document as well that we're going to kind of talk about. So when we are teaching the class with support, the first thing we do before we introduce a calculus topic is we have a short lecture, I guess you can call it, or just an interactive time where we're working through these problems together that are based on pre-calculus support topics. So these are the topics we feel they'll need to strengthen their understanding or to help them understand the calculus topic that we're going to be teaching soon. So Lisa's going to show you on the right side of the screen there what we have.
So here's an example for specifically our algebraic limits topic. So the calculus topic of algebraic limits. This is an example of our support notes. So we list the support topics. These would be the pre-calculus or pre-topics, factoring, rationalizing, clearing fractions, trig identities. We tell them what calculus topic they're being supported in. We list in words the key concepts that we're going to be reviewing, and then we go through these problems with them. Currently, our model is that students did have to pass pre-calculus, whether at Mt.SAC or in high school. So we do currently treat these a bit as review. You'll notice that, maybe the factoring problems don't start with like a basic coefficient of 1, and that's because these aren't the first support notes that they've had. They've had previous ones where we talk a little bit more about basic factoring. So, we're gradually kind of building up as we go. And then you can see we get into some quadratic form exponentials, some where identities are used. And and then a little bit of multiplying by the conjugate, simplifying complex rational expressions. And then we do give them a chance to reflect. You'll notice that theme that's pretty common is we try to give them a lot of opportunities to pause and think about where they're at in their understanding of these topics. Maybe write a little note to themselves that, you know, says, I need to review my trig identities, or I need to review factoring, go back and, you know, look up this topic. So it's just one page for this topic, one page of those pre-calculus support notes.
So one of the things I forgot to mention is we went over this in the first webinar, so we're just going to very quickly kind of breeze through it. If you are interested in hearing it in more detail, you can watch the recording. And we did provide these documents for the first webinar, and they are going to be provided again. So then after we do that in class, usually that's at the end of a class, then in between that class and the next class, the students will watch a calculus video. We use a website or company called corequisite, and it allows you to embed questions. And so we do embed questions sometimes on the pre-calculus topic, and then also ones on the calculus topic. Usually they're calculus topic questions that need the pre-calculus that we discussed in class. So students will go through the video on their own, take notes on that. And we actually, Lisa will show you on the other slide, the notes that we give them that are kind of blank notes. And then when they're done with the taking notes, they complete a check your understanding, which is just a quick, usually 2 or 3 questions that pertain to the topics from the video. And those questions give them practice on the calculus topic.
So just to show the example of what Paula just talked through. So we do have a blended class. So we do require video lessons. So after the in-class pre-calculus support topic lecture, they outside of class will watch a video lesson, and they have this set of notes templates to follow along with. So this little play button indicates to them that it's a video to watch. So they will watch the video lesson. There are embedded questions where it will check for understanding on both calculus topics and support topics. So there are multiple choice questions. The video kind of pauses. Someone once said that it's a lot like traffic school. I don't know. I haven't done that, but I get pauses, ask them a question, allows them to continue on to watch the lesson. So here, again, all these are provided. So you can scroll through it. So it goes through, these different examples of algebraic limits. And then this little stop button indicates, that's where the video stops. And then after they complete the video, but before coming to class, we ask them to complete what we call a check your understanding. And again, the reflection theme, it starts off with this little reflection after watching the video lesson. How well do you feel you understand the material presented so far? So they kind of circle where they think they're at. And then we tell them to use their notes to try to answer these limits questions, right, before coming to class. So they would have these completed before arriving at the next in class time together.
Yeah, and one of the things that Lisa and I both do is we use Canvas. And so we actually require them to submit it on Canvas before they come to class. So the advantage I see of that is that they've already turned it in. And so that's where they'll earn credit or extra credit for it. And then they'll have it also in front of them as we're going over it. So they'll be able to correct their mistakes if they made any and see kind of how they did. So then after that, they'll come to class the next time, and we'll spend the first part of class reviewing this check your understanding. That can be done various ways. Sometimes I'll have my students go to the board and assign students a problem. Sometimes I'll go over them. It kind of depends on how much time we have in class that day. And then after that, they will have a time to ask questions if they have any questions on that. And then they'll work in groups on the calculus assignment that pertains to that lesson. And depending on how much time we have that day, they usually have between 45 minutes and an hour to work on that assignment. They'll work in groups, and sometimes that will involve going to the board and writing up solutions. And most of that time we're walking around answering questions and helping them out. And their group mates are also helping each other out and answering questions. It's a very interactive time and very productive, at least in my class, and seeing them just helping each other out, which I try to remind them is one of the things you need to do as a STEM major: form study groups and, all that kind of stuff. This is your path. You need to be okay, asking each other for help. And then at the end of that time, right before usually we take a break in our class, we'll give them a no stakes, what we call in-class practice quiz. This is through Canvas, and it's something that's required, but we allow them to retake it. So let's say in class, they take it and they only get 2 of the 3 questions right, or whatever. If there's 4 questions, maybe they only get a couple of them right. They can go back later and take it again after we go over in class. So it's what we call no stakes, in terms of you will see the problems worked out. And if you missed one, you can go back and retake it after class. And we also encourage them, hey, right before the exam or a quiz or something, you can go back and take those again. It only keeps your highest score. So if you want to go back and try those out again, just to make sure you're up to speed on the topic, then that's fine. So we do allow them unlimited takes on those. So they're meant to be no stakes. You have to do them, and that's part of their co-requisite grade, but you can take them as many times as you need to.
Yeah, I'm glad you mentioned that. It is part of their co-requisite grade. So it's part of that support course where they can just, keep taking them over and over again. So we just wanted to show you now an example of the corresponding assignment. We did the pre-calculus support lesson. They went home and watched the calculus lesson at home. They did some practice problems within the video. They did their check your understanding. We went over their check your understanding. Then this is what they're working on in groups. So we do type out all of our homework questions so that it's handouts. These are the different algebraic limit problems that they have. See, it's a couple pages worth, maybe 4 pages worth. No, not even 3 pages worth of problems. You'll notice that we also have what we call spiral review. So on every homework assignment, we have questions from previous topics that we try to weave in so they can, be prepared for the exams, the final. So even when we've moved on to derivatives and integrals, we go back and put limits, and on integrals, we go back and put derivatives and limits. So we're really trying to get that review in. And then I kind of glazed over it, but at the top of all of our homework assignments, we do have a required reflection. Again, there's that reflection piece. Where when the students are working in class on these, they don't have access to the solutions. So they are just working on it together. They have access to each other. They can ask each other questions. They can ask us questions as we walk around. And then some of the questions are put up on the board. We have them go to the board and we go through them. But after class is over, on Canvas, we do post the full solution. So not just the answer key, but the full written solutions. And I'm thankful to have Paula because we split this work. So we split up writing out the solutions for all of our homework assignments. And so we put them on Canvas, and they are required to check their work and to make sure that they have the right answer. So after trying all of those problems, they have to review and either put a check or an X next to the problem. And if it's incorrect, to correct it, to write the full solution. And then really think about how many problems are you still struggling to understand? How much do you think you understand this topic? And we really tell them, this is for them. We are checking this. We do want to make sure this is done. But this is more of a guide for them as they go to take the exams to think about, oh, okay, algebraic limits. I gave myself a D level understanding. I guess I better go back and study that topic. Or, limits at infinity, I gave myself an A, so I don't have to spend as much time there. So teaching them that skill of, prioritizing topics when they, when it comes time to study for the exams. And we don't have an example to show necessarily of the no stakes in-class practice quiz, but they are calculus questions. They are calculus questions on this topic, but they count towards the support course grade. Right? So that is the end of that file. And oh, go back here.
All
Okay.
right, so to answer some logistical questions, we have a zero cost class. We do provide all the handouts. We also post all of our documents on Canvas, and everything is submitted on Canvas. We do have students, we provide all the handouts, but then we also have students who say they prefer, they have a tablet or a computer with a touch screen, and they do prefer to do use a stylus to do their homework. So we also on Canvas have all of the PDF files, so they can use those if that's what they prefer. So we do suggest labeling everything, whether it's a target course, the calculus course, or the support course, and to keep the two things, to keep it organized, because they are 2 grades. And we also try and print our support material in a separate color that we don't ever use maybe for the target course, just so that everything for the support course is that color. They can easily find it in their folders. And our video lessons tend to range from about 20 to 60 minutes. So they can be kind of long. But again, that allows a student more time in class for the part that students are usually doing at home, struggling on is the homework and stuff like that, where they're in class and they have their classmates and their professor there to help them to answer questions on that. So some other logistical questions in terms of our grade, how we grade. So we have 2 grades that we have to give, a support course grade, and at our school that's a pass or no pass. So usually pass is 70% or above, and no pass is below that. The things that go into their course for the support course, their grade, would be the notes. So that would be the Math 18A notes that we showed at the beginning, which is the prerequisite topics. Their daily in-class practice. Again, we talked about how we do that on Canvas, and that they are allowed to retake those as many times as they would like. Student success modules. So these are modules that Lisa and I helped with a group of other colleagues to create last year. These modules touch upon things like managing your time, or productive ways of studying actively rather than passively, and just various other topics that we feel will help them out through their STEM journey. We also give Math 18A exams. Those are taken right before their 180 or their calculus exam, and those are on Canvas, and they are a last chance to practice at the skills, the prerequisite skills that we feel they will need for the exam. So we give them some factoring questions or whatever we feel will be helpful to them as they sit down to take the exam. And then their final for that class, which is a take-home final. It's a Math 180 final exam review. So it's basically a calculus review of the whole semester. And this year, the semester, actually, we gave it to them at the first day of class and basically said, you can do this whenever. And I do have students who, before the exam, they'll go, okay, so the exam covers limits. I'm going to do all the packet on limits. And that also can serve as a review for that exam as opposed to just the final. And then it gives them less to do later at the end of the semester. Some instructors also include submitting calculus notes as part of the support course grade. So just to verify that they've watched the video and they have the notes there. And then for our target course, obviously not everybody grades breaks their grade down exactly the same, but Lisa and I are very similar. We do the assignments and the video lessons count for 10% of the grade. The weekly quizzes, we give them weekly quizzes except for exam weeks, and those also count as 10% of the grade. And then we give 4 midterm exams or exams, that's 55% of the grade. And then the final exam, which is cumulative, is 25% of the grade.
All right, so that was kind of a recap of what we did last time. And then the logistical questions were pretty much a combination of questions that were asked to us via email after our last session. So, people ask kind of those random questions. So we thought we'd share them with everyone here. But our focus for this session is going to be guidance on the design process if you are planning to create a support course. and just sharing some observations and additional recommendations that we have, and then just answering any questions that you have as time permits at the end. So design process. So the process of backwards design is something that we're just going to talk about sort of in general at first, like the basics of the idea of backwards design, if you haven't heard of it before. So the idea is that we start at the end of a student's learning journey, which is we start by looking at the student learning outcomes and the course measurable objectives to create those summative or high stakes exams, like the final exam, or any of those major exams. So, another benefit of this is that I think one of the concerns people have is, losing rigor, which is a very loose term anyways, but, this really makes sure that, at the end of the class, what are we holding students accountable for based on what we said we would in our, student learning outcomes or course measurable objectives. So starting there, right, making sure that we have, good solid questions on the final and on our major exams. And then from there, once we're confident about those types of questions, working backwards and making sure that we create a lot of formative, which would be low stakes or no stakes assessments or assignments for students to engage in practicing problems of varying difficulty with feedback given to prepare them for those summative assessments. So these could include quizzes and homework. Those are, tend to be lower stakes compared to those major exams and the final, or sometimes no stakes assessments, like if you give in-class problems, if you do any type of activities, if you provide exam reviews, sometimes those don't count as any credit. Sometimes people make it extra credit, but just giving a lot of, practice problems of all kinds of varying difficulty to make sure that you are preparing them for those big, major, high stakes final exams, major assessments. And then thinking about designing your actual calculus lessons, where you scaffold in that theory and the proofs and the examples of varying difficulty. So I remember, first hearing this, it is kind of backwards than I think maybe we all start when we design a class, which is a lot of people start with the lesson. And then maybe just go to the book and kind of say, every other odd problem, and then write the exam. And I was challenged, when I was in my ed program for my master's in education program, to go back and look at my finals and see if there is a lot of practice problems in my formative assessments that prepare students for those. And then whether my calculus lesson did prepare students for those formative assessments and those summative assessments. So it's just a really interesting take. And I think that it really lends itself to, what the challenges that we all are facing, and thinking about making sure that, at the end of the course that we are, testing those student learning outcomes and course measurable objectives, but that we're also just giving plenty of chances to practice those throughout all the different assessments that we provide. So this is all about just the target course, all about the calculus course. And then Paula is going to go ahead and talk about how do we fit that support piece in to this backwards design process for the target course.
Yeah, so as Lisa has said, when she goes through, sorry, I was answering some questions, so I may not have heard everything you said. She went through all the stuff on the left there. So as we're doing this, as we're looking at our SLOs or our final exam question that we want to include, and as we're creating our assessments, our quizzes, our homework, that kind of stuff, we are then identifying what are the prerequisite skills needed. Okay, and we do this by writing out all the solutions to all of our homeworks, our quizzes, our in-class practice, our notes, everything that we're making. And we think, what do the students need? What skills are important for them? And then we determine if there is enough practice on these skills within our homeworks and our notes. And then we determine if we need additional support assessments if they're needed, and then we consider making these multiple or ones you can take multiple times or unlimited, reinforce and to build their skills. And then after we do that, we design just-in-time support lessons. So those were the prerequisite skills that we feel, okay, these are the prerequisite skills we need to make sure they have. And so let's create a little lesson about that. And then also something we do sometimes is to provide additional content for students to review on their own. We have created some interactive practices, we call them, that go back and review some of these concepts. So if a student says, man, I'm really weak on factoring, or I still have to use the X method every time I factor, and we can say, okay, well, you should work up to kind of doing guess and check, and we might provide them with some support, whether that be something we've created or just a video outside of class that we might want to say, if you need more help on this, then you can look at this. So what we're going to do now is kind of break up the lesson that we just looked at and kind of talk about how we worked backwards from that. So we looked at some questions that we have on our exam and on our final. And these are the ones that we could find that deal with factoring. And then after that, we then said, okay, so now we can see the skill that they need to know how to factor. And then go ahead, Lisa, you're going to take on the next slide there.
So from there is, when we're creating those formative, like low or no stakes assessments. So what we did was we found all of the different places in these different pieces where we had practice for this. So going kind of through one at a time. These were questions from our assignments or homework on algebraic limits. So we had, 3 different problems that are in the assignment. So there's some practice there. Here's a question from one of our quizzes, right? So a low stakes assessment where they're getting practice. Here was an example. Sorry, it's a little pixelated, but we just kind of did a little screenshot. Here was an embedded video question. So as they were watching that video lesson, this was a pop-up question that was off to the side for them to answer in multiple choice form so that they're getting immediate feedback. And then this is a check your understanding question on algebraic limits. So involving some exponentials, but still factoring there. And these were 2 questions from our calculus exam review. So that big final exam review that we had 2 additional questions there on factoring. So we felt like, we had a couple problems on the test and the final, and then we have all of these different examples where they're getting practice and feedback to kind of check how they're doing as they go. And I think one of the things I wanted to mention here was the level of feedback. So as I mentioned, we do post the full solutions to our assignments. So they get like full feedback there. And same thing with the check your understanding. So we do go through in detail the solutions to those problems. But the quiz questions, that's hit or miss. Sometimes it varies, but I've given some quizzes on Canvas and some quizzes in person. If it's on Canvas, they're getting feedback just in the form of right or wrong. If it's in person, I do write out the full solutions and I go through the quiz afterwards. So they are getting full feedback on the quizzes. But the embedded video questions, they're just seeing the right answer, right? Just whether it's right or wrong, and then seeing what the right answer is. And for the final exam review, that's also just the answer. So we don't provide the full worked out solution for the final exam review, just the numerical answer, or if it's derivative, the final simplified answer. So they're getting various levels of difficulty in the problem, and then various levels of feedback. Of course, they can always come to office hours for full feedback on everything, but that's just what's sort of built in there. And I believe I'm doing this one too. And so the next level here is to, design your calculus lessons to scaffold theory and examples of varying difficulty. So we just snipped out the examples part. So we kind of go through the idea of, why we are allowed to factor and cancel and what's happening graphically and everything, right? But we only included the problems here. But here are some questions from the notes. So one where it's, algebraic functions and then some exponential functions, both involve some layer factoring of some kind, but it's far less. So I think, something that we've observed is, and that we, feel is important is, yes, to go over, examples with students, but it's almost like less is more there. Where we really want to make sure there's a ton of problems is that practice piece, right? So we only go over these 2 questions and then the theory of why we can do this. But, whoops, let's try and go backwards. This is the biggest page, right? The practice page for them and on all those various types of examples. That's the biggest chunk. So it's like, we really feel they need to struggle with it, to practice with it, not see us, do, tons and tons of examples there.
Okay, sorry, I was responding to a question. All right, so after we've set the goal, we've figured out what the practice is going to be, we've developed the lesson, and then we identify the prerequisite skills needed by writing out the solution. We said this, so we go through and go, okay, before they sit down to take this exam, what's going to be some things that they need to know in terms of the prerequisite skills. And so this is what we create is a Math 18A pre-exam. So these are the questions that some of the questions that we had on our, I guess our second pre-exam, first pre-exam, because we did limits on our first exam. And so these questions were ones that they need to know how to do. And we assign this on a Canvas quiz. It's a multiple choice. And it's due the day right before they take the exam. So these are skills that they'll have fresh in their mind that they just practiced right before they'll take their calculus exam. And then after we've identified that we need to do that right before the exam, we look at, okay, how are we going to provide them just-in-time support? So what are we going to do in class to support the lesson and to bring to their mind these topics that maybe they haven't seen in a while? So these are the questions you'll see there from the Math 18 class notes. Those are the questions that we provided, or we went through with them in the class. And then here are some questions that we had on the in-class practice right below that. Different questions in terms of just factoring, which then, finding a limit through factoring. And we also have interactive practice, like we mentioned before, through Canvas, which will help them strengthen their factoring skills. All right, so, oh, this is Lisa, go for it, sorry.
All right, so we kind of went the backwards direction. So now we wanted to kind of look at it from the student perspective, this like follow through. So they're getting that pre-calculus support lesson, right? Then they're getting the calculus lesson with embedded pre-calculus skills, right? Because, obviously we go through the pre-calculus as we're teaching, the calculus topic, we show the factoring, we show those skills. And then calculus practice with embedded pre-calculus skills. So as they're doing their assignments, as they're doing the in-class practice, the check your understanding, those all have embedded pre-calculus skills in it. And then they, in our class, have a pre-calculus focused assessment to prepare for the calculus exam. So that was, as Paula was describing, we give for the support course a Canvas exam that they can take more than once on just the pre-calculus skills that they may encounter in their calculus exam. So focusing on factoring, conjugates, and graphs and all that stuff. So but with the idea of that chance to do it again, so that it's on Canvas, they could take it again and focus specifically on those skills, and then they take their calculus exam. So kind of all leading up to that high stakes assessment, but they've had just layers and layers of practice as they go along. So that was kind of our, design process, what we think sort of worked for us. And now we just want to go ahead and share some of the observations that we've had and some recommendations that we have that also fall along the lines of promoting equity. I think it's a really good idea to provide a daily agenda on the board. Our support courses, Paula and I specifically, are back to back. So it's like a 3-hour, slightly more than 3-hour class. And I think that on some level that can be daunting. But if the students know what's coming up and they kind of see the breakdown of what we're going to do, it helps break things up, and they are getting that chance to go up to the board and to work in groups. But if they know what's coming, I think that's really helpful, putting up that quick agenda on the board. Something that I wish I would have started doing earlier is setting goals for students. When they come out of a video lesson, I tell them, I don't really expect you to have 100% understanding. We don't get really good understanding until we practice ourselves, right? But I do think that when you come in, you should get going, right? You've tried those check your understanding problems. Now if you made a mistake on them, we've hopefully clarified that issue as we went over it. So here's the goal for today, right? So the assignments that we provide, I kind of look at it, and after doing it for a few years now, I kind of have a feel of like, you can definitely reach number 8 if I give you 45 minutes to work on it. So I think that's a good goal. And it took a while for me to figure out how much time, but I think setting a goal is a good idea, because otherwise, especially as the semester goes on, if they have really good chemistry, they may take some time to like chat about their weekend and whatever. So I think it's like good to set those goals, and then just to walk around a lot and to check in. And I really, try to build that culture of like, don't hide your work as I walk around. I think some people don't want you to see if they made a mistake. I'm like, now's the time for me to see where, there's room for improvement. Now is better than on an exam. And, don't be afraid to ask questions. And so I think walking around just a lot will get them to kind of ask more questions. As we have said too, this is something that we suggest because we do it, having students write their full solutions on the board. This is definitely a place where we can create that culture of learning from our mistakes and addressing errors like notation errors, parentheses. With the classes, you look at the board work together. So they, go up and they write their full solution on the board. And then I go through and I look at each one and I do correct it as I go. And I say, don't like stop coming to the board because I corrected what was up here, take it as a learning opportunity. The common notational things like they don't write limit every time, or they put like dx equals, or like don't put parentheses, all that kind of stuff, forget the differential. And so I'm, writing it down like, yes, you have to do that. And, I think those are really good times to correct those mistakes if you have them write their full solutions up on the board. Obviously, have a positive attitude while answering any question, especially from the prerequisite material. I may do this with a grin sometimes if I know I just said that, but, I think it's important to keep that positive attitude, even if you've gone over how to factor the difference of squares every day for the entire semester and they're still asking how to do it, right? It's still important. It just like creates that culture of still being comfortable asking questions at any point in the semester. And, I do have students that say, I know I'm not doing well in this class and I'm probably going to have to retake it. So I know I'm behind, and maybe they're asking questions about the previous topic because they're still just trying to learn as much as they can with the intention of maybe taking it again. So, I do try to just have that positive attitude. Like, I'm glad you're here. I'm glad you're still trying to learn what you can and when you can, not wasting time. Always using positive affirming language, like you just don't understand it yet. And, trying to be motivational and inspiring, that with enough time and effort, they will understand it. If you have personal stories, I actually have all my old calculus stuff, and I show them how I have an old test with like a related rate problem where I was like, what was I doing on that? And I show it, I have it, and I scanned it in and I put it up on the board, and I'm like, wow, what's happening here? This was my test. And maybe all of you were just great at related rates when you first took calculus, but I didn't know what was happening. And so I think that helps, that like, oh, wow, they like, she didn't understand it and now she's teaching it. So I think that that's really helpful. And then we do try to create a syllabus that's really welcoming. And we try to have policies that allow for mistakes as part of the learning process. Like we said, we give multiple chances for, certain assessments. And, we do provide the answer key to our assignments because we kind of feel like they're out there anyways, right? Like all the solutions. So if you're tempted to copy off of somebody, copy off of me, because I'm going to write out every single step of the problem, so that you can figure out where you're potentially going wrong there.
Lisa, before I go over this,
Yes.
there were a couple questions that I think you could answer better live. Two people had asked, how much release time do you think someone would need to create these co-requisite or support materials? I know you were a part of the initial group that did that. Not that the materials we use are ones that you guys created during that time, but do you remember how much time you guys were given? It was 2 people per subject, correct?
Yeah, it was 2 people per subject. So originally at the onset of our support courses, there were 2 people per co-requisite support course, and each person got 1 LAG. It was not in any way, shape, or form enough time, and that was only for worksheets. So in that first go round, we kind of just made worksheets. So I think at that point the process was, let's look at each chapter and then pull out some support topics from the previous class and just make some worksheets of that with an answer key, from what I remember. So this whole process took a lot longer, right? So even that was more than 1 unit of release time. But this process, which I think is really important it's just going to be really different soon too. But this process, I think, if you're going from a class where you, don't already have any form of like typed out notes templates, or especially any form of like typed out homework, a lot of time, I don't know. But I think it's splitting it up. I think a team is an important aspect of it. Yeah, working with some colleagues on it, and kind of splitting up the work. I don't even know.
I mean, this is what you see is what Lisa and I have revised and revised and revised semester after semester after semester, and added things and taken away and done this and done that. So it's been since 2018 that we've been working on this. So there was another question that I just wanted to answer really quickly. What textbook do we use? We don't actually require a textbook for our course, but the rest of our department uses Stewart. And we do follow along in terms of, we say this is from this chapter or this section, because there are some students who do have the book. Maybe they already took the course and this is their second time. And we do use it in our classes after. So the second semester of calculus and our multivariable calculus all use that same book. And so we are kind of say to our students, you don't necessarily need it for this class, but you might need it for the next 2 semesters. So you might want to think about buying it now. So that's something else that I just wanted to answer really quickly.
I can also answer the most recent question live. I'm going to click answer live. Are the 55% exams and 25% final exam all in person, on paper, traditional method of taking exams? Yes. So
Yes.
we do have a department policy where our final has to be cumulative, in-person, closed book, closed note. So that's the 25%. And then there's also some policies depending on how many units the course is, like how many exams to give. So, between 2 and 3 exams or 2 and 4, like midterm exams that are also closed book, closed notes, in-person exams. Now, we do have asynchronous courses, so those don't fall into that category. But for our in-person or synchronous, any level of synchronous courses, hybrid synchronous courses, those are all in person. We do have like a addendum that if a portion, and it's a small portion, I couldn't tell you the percentage, roughly like maybe 5 to 10% of each exam. If we wanted to give a portion of the exam as some type of project, we could, but it's like a minimal portion. So like an individualized project, like maybe a project on Desmos, or graphing utility of some kind, a computer-based assignment, that could be a portion of the exam, but like a small portion of the exam. So that's the answer to that question. So it's about, so 80% of the course grade is closed book, closed notes, traditional written exams.
Okay, so this is our last slide. Why don't I go through this one and then we'll take the time to answer some of the other questions that are there, because we do have enough time. I think we'll be good. So the last thing we want to talk about is just helping students form their STEM identity. So we do, as we talked about before, have what we call modules. They're called student success modules that go over what we consider some of the hidden curriculum of college, in terms of, this is how much time you should be spending on a college level course. This is where you can go to get help. This is what office hours mean. Why are you here? What are the reasons why you're in this course? Let's keep those in mind when you're sitting there going, I just don't want to do this homework. Keep your goal in mind. And also, as we said, time management, avoiding distractions, those kind of things we also have modules for. The feedback we've gotten from our students are that they find those helpful, and they give them some things to think about. We also, as Lisa mentioned, share a little of our personal STEM path and discuss how majoring in STEM is a way of life, kind of. It's not just something you do on the side. It's time consuming, and you do need to make friends, and you do need to form study groups. And these are all things that we did when we were in college to help us get through the STEM path, and that those are things that we encourage them to do as well. We also give constant reminders of how much time they need to be investing in the class. This is a 4-unit class with a 2-unit corequisite. That's 6 units technically. That should be about 12 units outside of class. I kind of reduced that a little bit. I say somewhere between 10 and 12, because they do have the support is going to add a ton more time to what they're doing. And so, that are you spending, if you're not happy with your grade, look at how much time you're spending in the class. Are you spending 10 to 12 hours? And it could be more than that if you need to go back and review more of those prerequisite topics. As we look into the future and think about students who have not taken precalculus, who are going to try and take calculus, those are things that they need to keep in mind. If you see something in class that you don't understand, you need to go back and review it. And we encourage group work, obviously, from the first day. We do have an activity that Lisa's going to put up on the screen that we do the first day of class that serves multiple purposes. It's to give them a glimpse of some of the math that we're going to be doing in terms of what we kind of need them to know or want them to know, or what we'll be reviewing with them if they don't know. And it gives them a chance to get used to being in a group. So we ask them, introduce yourselves to your group members, write down their names. And then we ask them some questions. Like the first one there is, how do you graph this line? And then we ask them, how would you rate your understanding of this on a scale of 1 to 5? 1 meaning that I couldn't do it on my own, 5 meaning that I could do it on my own, but they're doing it as a group. And then the second question there is just match these equations to the different functions. So they would just write the equation for each one. And again, how could you do this on your own or not? What's your level of understanding of it? And then C, factoring a trinomial there. Again, rate your level of understanding, and then solving a trig equation and rate your level of understanding. And then at the bottom, we have them discuss why did you decide to take this class with a co-requisite? Talk about this with your colleagues or your group mates, sorry. And what we're kind of hoping to, and we usually have a little discussion afterwards, what we're hoping to bring up with is, hey, everybody has different strengths and weaknesses. And this is one of the things that a group allows us to do is you may have been able to do the trig equation, but maybe you forgot what those graphs were. And that when we work together, everybody brings their strengths in, and it can be beneficial to everyone in the class when we're working together and figuring this stuff out. And this semester I've had some really great groups in my classes, and just most of the groups in my classes are just like, all right, let's work on this one. How do you do this? Oh, thanks. And they're like giving each other high fives and stuff. I'm like, wow, this is really cool. So this is our first day activity. I don't know, Lisa, if you wanted to add anything to that.
Oh, no, I just agree. I have really great groups, and I work really hard to get really active groups at the beginning of the semester. I mean, for my own sanity, because I'm like, if they're not talking, it's in this setting, we have so much time to do problems, it is agony and it's just awkward. So I let them know, in the classes that I've had in the past where there's really good, group work, and I can hear them say like, okay, after class, you want to get lunch and then go to the MARC, which is our math center. Those are the students that do the best, the ones that form those connections. They take the next class together. So I really try to emphasize that at the beginning. And I think that it pays off, that like initial investment of really getting them to work together and to not be afraid to make mistakes and, get to know each other. I have great groups this semester too. All right.
Okay. Go ahead, Lisa.
Yeah. So we planned a less time for this session than the last one, so that we could answer questions, because we know that last time we didn't get around to all of them. So I accidentally clicked one that said answer live, and then I answered it by typing. So I just want to make sure that person got the answer. Do you allow note cards or notes on our exams? No, neither of us allow notes or note cards on our exams. I didn't understand one of the questions that said something about, oh, maybe it got answered already, about proofs. So we do proofs in the course of various topics, and I have assess on the proofs. I've had them do some of them in the class. So there was something about how do you meet a requirement if you don't do proofs? We do. I'll answer live this one. Do students have difficulty reading your solutions? Have you incorporated reading apprenticeships types of discussions so students feel comfortable reading mathematical writing? That's interesting. I have never felt like that was an issue. Personally, I don't know if Paula wants to chime in on that, but I really feel like we attempt to do like step by step solutions, even sometimes describing what happens from step to step if we feel like it's complicated, like putting an arrow like distribute, or from here to here we used this trig identity. So it's not like just where did this come from? So there's like a real attempt at showing where stuff comes from. But I think maybe you're talking about like a language issue, maybe like an English language learner.
No. Okay. He's shaking his head no. So
No.
But yeah, I mean, we do have obviously some proofs and stuff on the homework. And so I guess there could be some difficulty in kind of looking through that stuff. But like Lisa said, most of it we lay out step by step, not necessarily for calculus, but like I also teach statistics, and in that class I do a lot of like, you need to show this step, you need to show this step, so that like they know, oh, on the solutions, because I provide solutions for those too, that, that's what I'm expecting to see. So
I'll answer. Do you think it would be possible to integrate an online platform like My Open Math that automatically grades homework into this model? I mean, I definitely think that's possible. I do not have a lot of experience with online assessments. They are not my favorite thing, but I mean, I definitely know people who are like great with manipulating it and just everything. I just, I guess I prefer like traditional written assignments, or maybe like a combination of them. But I definitely think that's possible. I would just say if it's, to see if you can still see the really closely the type of problems and how they unfold. I think that's what's interesting, is even as we're writing up solutions, I'm like, oh, I didn't mean to put one like that, and you don't realize it until you work through it. So I think that's kind of a downside of online. Is sometimes it's like you want to put like that randomization aspect, but then, are they really equivalent in difficulty to all the others? And, were you intending to get, that specific skill tested on? So I don't have a lot of experience, but I'm sure it's possible.
Yeah. There was another question I'll go ahead and answer live. Do they stay in the same group throughout the semester? I think that's individual. Instructors do that differently. I tend to give them a week to kind of get settled. And then the second week I kind of go, okay, wherever you sit today, that's going to be your group. And just by chance, it's worked out great. Now, as I have students that drop, because obviously there are students who end up dropping, I do shuffle students around. So I'll go, okay, I want you to go move over and join that group because your other group mates have dropped the class, or, whatever, or two of them. So you go here and you go there, so I do end up having to move groups around. I was actually thinking it was about time for me to do that for my class, because I have a couple groups that I usually am like, okay, well, your group mates aren't here, so why don't you move up and to this group? And so, they do sometimes change. Those who have some.
I'm going to answer this one about, with extensive reviews for midterms and the final and for midterms, how do we avoid teaching to the test and encourage large-scale integration of the concepts and techniques of Math 180? So I do not have reviews for the individual midterms. We do have a review for the final. It's 30 pages long. I wouldn't say it's the type of thing where it's the final with numbers changed. Like, that's definitely not our philosophy at all. So it's varying difficulty. Like I said, it's a 30-page final exam review, and I don't give exam reviews for each individual exam. But my belief is, though, that if we're testing on it, and this is a personal teaching philosophy, that it should have been taught or practiced in some assessment or lecture notes. So it's part of why the homework assignment, I tell them to value their homework assignments a lot. So I do believe that if you have done all of the homework and you have watched all of the lessons and done everything I give, which is a ton of resources, that you should be prepared for the exam. So I don't know if you would consider that teaching to the test. And if you do, I don't know what to say about that necessarily, but I do teach the concepts. I do feel like I assess on the concepts. I have vocabulary on my exams. I have proofs. I have application problems, but I have them on the exam, but I also have them in their assignments, in their previous quizzes, in their lecture notes, because if I'm going to put it on an assessment, then I feel like they should have seen it and been able to practice it at some point in the class.
So there's a question about sharing your SLOs. Those are available. So, I mean, we could share those at some point, maybe put them in the drive. And for the support course, yes. Okay, so we have different SLOs for the main course and the support course. And so, we can, I'm going to go ahead and put that I answered that live. We'll go ahead and I'll write a note to myself to put those into the shared folder, so you guys will be able to see those.
And those have evolved, the student learning outcomes for the support courses, because our support courses were previously like courses on prerequisite content only, versus now they can be support for the target course. So we had to go back and adjust our SLOs. So that has changed over time.
Somebody asked, what differences or changes do we anticipate for the fall? We thought our fall would be for any student can take calculus, but we weren't. I guess we just recently talked to our department chair. We weren't able to get the paperwork, whatever. I'm not big on, I don't know all those words, but things done. And so apparently next year will stay the same as this year. Is that correct, Lisa? That as long as they've taken pre-calculus, whether it was here at our school or another community college or at high school, then they will be eligible for calculus. And so in terms of differences, that's how it is now. So I don't necessarily think that there's going to be much of a difference, but for the following year, where it will be anyone who is a STEM major can sign up for calculus as their first course. I honestly, I don't know how that will be different. And I guess that will be a bridge we'll cross when we come to it. So there's a question here about business calculus. We do have, there was another question related, I'm not sure if it's still here, about that somebody said they have a business. They're worried about being so STEM focused in Calculus 1 because they do have non-STEM majors who take it. Yeah, we do have a business calculus course, but we do also have business majors who take the regular calculus. I think it depends on where they're planning on transferring in terms of what course they need. And so yeah, the business calculus course does not have any trig, so that is a different course. And we do have a corequisite for that class as well. I don't teach it, so I'm not sure how well that's worked. My office mate does, but I haven't asked her. I don't feel like it's a bad thing to be STEM focused in your Calculus 1 class, even if some of your students are not STEM majors, just because a majority of them are. And if I can encourage those who are to stay with it, then I want to do that. And if some non-STEM majors have to hear a little bit too much about STEM, well, I don't feel bad about that. Maybe they'll change their mind and become a STEM major. Lisa, do you have anything?
I was just going to ask or answer about, have you been able to collect evidence of the impact on student Calc 1 course completion and or throughput? So we do have some data on our Calc 1 course. I'm assuming you're talking about Calc 1 with support. And it has varied over the last couple of semesters in comparison to our Calc 1 class. So our students self-select to take calculus with support. So that is not required for any GPA band. They're self-selecting to take our Calculus 1 with support. That being said, that if we were to compare the Calc 1 with support to the regular Calc 1 course, it has jumped back and forth, where it's been lower than the Calc class without support, and sometimes where it's comparable or even a little bit higher. We actually anticipate calculus with support being lower because the students are self-selecting to take that class, and those students may have traditionally come from pre-transfer level pathways. So this is a huge jump for them to start in Calc 1 with support. So I mean, we do have data. I'm not sure if the other question, because there's another one about collecting data on specifically our courses. We have not done that. So like this model that we use with like the flipped approach and all of our resources, we haven't compared like our support course to like our colleague support courses or any others. We don't have data on that. So we just have data about our Calc 1 course completion. And our throughput, I don't know if you're talking about throughput for the next class, because not everyone needs to move on to take Calculus 2. So that we've also kind of found to be like tricky, you know, whether like our students dropping out after taking Calc 1, or did they just not need Calc 2 in the first place, because some business majors only need Calculus 1.
There was another question about data as well. We do regularly look at data, even data that's disaggregated by ethnicity and certain things. Our data guru is not in our department anymore, but so I think we haven't quite been looking at it as regularly as we used to. I know that shortly after we switched to corequisites, I'm really bad with remembering things, so I can't tell you what that data looked like. I don't know if Lisa remembers any of it.
Not really.
Yeah.
So the next question I'm going to answer is I really like self-reflection built into the first day group activity. What would you do with a student who couldn't do any of it? Could this happen with the new enrollment rules this fall? And are you anticipating hot topics that will need more attention this fall? Because I also feel like that goes with, how do you feel your approach will work when you brought in access to AB 1705? So I feel like we're kind of answering both. So as it stands right now, I don't know how much I feel like it's going to change that much. So we currently allow students who take took pre-calculus in high school, but this is self-reported. So our assessment questionnaire to enroll at Mt.SAC is self-reported. We allow students to self-report whether they pass pre-calculus in high school and then therefore to be eligible to take our calculus class. I kind of don't anticipate the population being that much different. I don't know. I might be kidding myself here, but I mean, because there already are students who come in that don't know how to do any of it. And I definitely try to just, broadly on the first day of class, say, don't compare yourself to other people, and, figure out where you're at and what you need to do to get to where you need to be. And, come and talk to me about it, and we can kind of figure things out. I also provide a whole website. So I've had a flipped classroom since I was a high school teacher. So I have trigonometry, pre-calculus, Calc 1 and Calc 2 videos on almost every topic. So when a student's like, I really need help, I'm like, well, I can give you like the full lessons, because clearly we're just reviewing in a short amount of time, but I'm like, I can give you full video lessons on all of these topics. But then, this does put like the burden on you to attempt to learn, 2 full topics at one time. Or, of course, they can self-select to go ahead and place themselves in a lower level class. We are still going to be offering a 1 course and a 2 course sequence into calculus. So that's going to just be a decision that they have to make. But I don't know if I anticipate it really changing that much. I really have varying abilities right now in the class. And I just try to say, stay as long as you can, learn as much as you can. I tell them I've had success stories where students took my class and they didn't do well, they didn't pass, but then they come back the next semester and they do great. They get an A or a B. And there's no reason to think that can't happen for them. So I kind of feel like that's.
There was a question on, do you reduce points on the video notes if they're not submitted to Canvas on time? So I'm rather lax with my due dates. I do say this is when the video is due. If they don't have it done by then they're coming to class working on a homework assignment that they have no idea how to do because they haven't watched the video. So you do that once and you kind of realize, oh, I need to watch the video before class. I allow students to turn in homework late. I usually don't reduce the or notes or whatever it is. I usually don't reduce the grade unless they turn it in after they've taken an exam on that topic. And then I tend to give them half credit because I want them to have the motivation to get it done before they take an exam. So that's it for that one. I don't know, Lisa, if you have anything to add on that.
I am also fairly lax with I don't reduce points on it. Like Bree said, pretty much up until the exam. And I think the other reason for that is because I post solutions. So I kind of feel like if I'm like, oh, you have to turn it in by the due date, that's just encouraging them to copy off the solutions versus like if you need an extra day or two so that you sit there and you do it and you look at the solutions the way you're supposed to look at and use the solutions, then that's what I'd rather you do. I just tell them to email me and say, I'm unable to turn in the assignment, to give them like a little bit of a sense of accountability, but I will have it by this day. I will submit it by this day. That's something new that I'm doing this semester, is, having them say, can I please have an extension? And I say, I will grant it, but let me know, and then hold yourself to a date that you can be held accountable for. So can I have an extra day? Can I have an extra 2 days? And then submit it by that new time that you say, so that you're not just like, I can turn it in later, so that you hold yourself accountable.
So I see 2 questions that we might be able to answer in the next minute. And then that's when we're, okay, it's 2:15. Let's go another minute. Do you feel that students who actually need the support are enrolled in the course? And do students who do not need the support take your course? I do have some students who I would say maybe wouldn't have needed it, but it's hard to know because if they didn't have the support, maybe they wouldn't be doing as well as they do in my class. And this last question, how do you advise and reach students who may need the support course? That's something we're working on as a department right now, because we do feel as though more students would take our course if they knew about it or understood more about it. And I think that getting the word out to students is a big as a struggle. And so that's kind of one of the things we're trying to focus in on now as a department, is making sure the students know their options and that they can take this course. And then it looks like Lisa answered the other one I was going to answer live, but I think we're good.
All right, so why don't we wrap things up? I want to thank you both again so much for doing this 2-webinar series on your experiences with teaching STEM Calculus 1 with support. You did an amazing job answering 37 questions while you were also presenting, so I appreciate that also. I wanted to mention 2 things very quickly. As you probably have heard, there is a $64 million allotment for AB 1705 that was approved last year by the legislature to fund implementation. And if you want to look up where that is in the ed code, you will see, I'm going to give you the citation right now, you will see that the legislature intends this money, a lot of it, to go to release time. So I encourage you, if you're out of college where you are going to, with integrity, take on a Calc 1 with CoRec and you want to get an early start, you need to be saying to your college, look at this part of the ed code. It's supposed to be going to release time. The ed code number is 78213.2 and it's section E. So it's 78213.2 section E. So anyway, I encourage you to do that, and don't go for a little, 1 hour of release time. You should ask for a full course release at least, and you should ask for a team of 2 people, as Lisa said, to be working on this together, because this could have a huge impact on addressing the disproportionate impact of our current calculus eligibility rules, right? We really could be making a difference here if we all put our creative and intellectual energies to this in the way that Paula and Lisa have. Second thing I wanted to say in closing is we have one more webinar next week in this series. If you join us on April 21st from 2 to 3 o'clock, you'll hear Cuyamaca College's approach to their new Calculus 1 with corequisite support. And if you haven't registered, you can go to the event page on the California Acceleration Project website, accelerationproject.org, and register for that event. I want to thank you again, Lisa and Paula. It's inspiring. And I just think there is such beauty in the way that you have designed and thought through this support experience for students. It's really awesome. It's inspiring. So thank you again, everybody. Hope to see you next week.
Thanks. Have a good weekend.
Thank you.
Thank you. Bye.
Thank you so much.